Today we're going to look at how to calculate the percentage composition of a compound. We can do this using this formula. So the percent of a certain element in a compound is going to equal the mass of that element in the compound over the total mass of the compound times 100%. So really like you would calculate any percentage. And there are two methods used to do this, and actually a better way to put that would be there's two places where the masses can come from. You will always use this formula to calculate the percentage composition. So the first method is when you know the chemical formula of whatever compound you're talking about. And if you know the chemical formula, you can calculate the percent composition using the molar masses of the elements and the compound. So if we look at an example, if we want to calculate the percentage composition of sodium chloride, an NaCl, we're going to use the molar masses. And we're going to assume that we've got 1 mole of everything. So then we can just use the unit of grams. So if we've got 1 mole of sodium chloride, it's going to contain 1 mole of sodium and 1 mole of chlorine. And we know this from the chemical formula. So the mass of sodium in 1 mole is 22.99 grams, and the mass of chlorine is 35.45 grams, and those are the molar masses from the periodic table. We're also going to need the mass of sodium chloride combined, and so that's 58.44 grams. So now that we have those masses, we can use our formula. So the percent of sodium is going to equal the mass of sodium over the mass of sodium chloride times 100%. So 22.99 grams divided by 58.44 grams times 100% gives us 39.34% sodium. And then we do the same calculation for chlorine, except using the mass of chlorine. We still have the mass of sodium chloride on the bottom. So in this case, it's 35.45 divided by 58.44 times 100% gives us 60.66% chlorine. And notice that the answers are given to 4 significant figures because our molar masses have 4 significant figures. And if you look at those two percentages, you might notice that they would add up to 100%. So if you determine the percent of all of the elements in a compound and you add them all up, it should equal 100%. And this is a good way to check that you've done things properly. Let's look at another example. Determine the mass percent of carbon in sucrose, which is C12H22O11. So this time we're just calculating the percent of carbon. So in 1 mole of sucrose, we know there are 12 moles of carbon because it's C12. So the mass of carbon is going to be 12 times 12.01 grams, which is the mass of 1 mole of carbon, which equals 144.12 grams. Then we're going to need the mass of the whole compound. So we calculate this just like we've been calculating the molar mass of compounds, and we get 342.34 grams. So then to calculate the percent of carbon, we're going to take the mass of carbon over the mass of the whole molecule, C12H22O11, times it by 100%. So 144.12 divided by 342.34 times 100% gives us 42.098% carbon. So what this means is that in a sample of sucrose, just over 42% of it is carbon. So the other method is if you're given experimental mass data, and often this will be used when you don't actually know what the compound is that you're working with. In this example, you carry out an experiment where there's 3.45 grams of sodium metal reacted with 5.33 grams of chlorine gas, and that gives you 8.78 grams of sodium chloride. And so notice that 3.45 plus 5.33 equals the 8.78. So in some questions, you might not be given all all the three data, all the three numbers, because you can determine them. Right? If you were only given the 3.45 and the 5.33, you could add them up to get the total. Or if you were given the total and only one of the elements, you could subtract to find the other element. So we calculate the percent composition of sodium chloride using this data. So given in the question is the mass of sodium, the mass of chlorine, and the total mass. So to calculate the percent mass of sodium, we just take the mass of sodium over the mass of the whole compound. So 3.45 divided by 8.78 times 100% gives us 39.3% sodium. And then for chlorine, the mass of chlorine over the mass of sodium chloride, 5.33 divided by 8.78 times 100%, so 60.7% chlorine. And so you might notice that these are very similar numbers to the ones we obtained when we determined the percent composition of sodium chloride using the molar masses. They're just not quite as accurate. They don't have as many significant figures because of the data that we're working with. So what this tells us is that when you have a sample of sodium chloride, it's approximately 40% sodium and 60% chlorine, right? Whereas if you were to just look at the chemical formula, NaCl, you'd think, well, it's half sodium, half chlorine. And in fact, it is half sodium atoms and half chlorine atoms. But when you then take into consideration their masses, the percent by mass is actually that there's more chlorine than sodium. So those are the ways we can calculate percent composition.